Welcome to The Explainer. Today, we are going to tackle something that's really at the heart of AI. How in the world does a machine actually make a plan?
So, let's just start with a simple question to get us thinking. How does an AI decide what to do next? I mean, we plan things all the time, right? But how does a machine sift through all its options to actually hit a target? Let's dive in and break down that logic.
Probably the easiest way to get our heads around this is to think about something we all do, planning a trip. You have a destination, right? That's your goal. So you figure out the steps. You book a flight, you pack your bags, you get to the airport. Well, an AI does pretty much the exact same thing, just with actions instead of airline tickets. It's really all about creating that perfect sequence to get from A to B.
All right, so let's dig a little deeper here. When we say an AI is planning, what does that actually mean in technical terms?
Okay, so here's the formal definition, and it's super important. A plan for an AI isn't just a to-do list. Not at all. It's a sequence of actions, and here's the key part. Every single action has two things tied to it. First, you've got preconditions. These are the things that have to be true before you can even take the action. And second, you've got effects. That's how the action actually changes the state of the world. It's like a perfect chain of cause and effect.
So, if you're the AI, you basically have two main ways to think about building this chain of actions. You can either start from the beginning, or you can start from the end. And this is where things get really interesting because you've got this classic trade-off. On one hand, you've got forward planning. This is where you start from where you are right now and you explore every single possible move you can make. It's reliable, what researchers call a sound algorithm, meaning if there's a solution, it will find it. The big downside? It can be painfully slow because there are just so many paths to check. Then, on the other hand, you can work backward from the goal. This is way more efficient, right? Because you're only looking at the actions that are actually relevant to what you want to achieve. But, and this is a big but, it's not always sound. You can end up with a plan that just doesn't quite work because of some inconsistency you didn't see coming.
Okay, so these two basic methods, forwards and backwards, they have their limits, and early AI researchers ran smack into one of those limits when they faced a puzzle that, to us, looks almost ridiculously simple, but for their computers, it was a total showstopper. It's famously known as the Sussman anomaly. See, the problem was that these early planners couldn't interleave their goals. What that means is they couldn't juggle tasks. They had to achieve one goal completely, check it off the list, and then move to the next one. And that simple limitation, well, that turned out to be a massive problem.
And here it is, the famous block world problem. It's so simple, right? You've got three blocks, A, B, and C. The starting setup is on the left. The goal on the right is to get a neat stack, A on top of B and B on top of C. I mean, a toddler could do this, but for those early AIs, this was a complete nightmare.
So, why was this so incredibly hard for an AI? Well, think about it. The simple planner looks at its goal list. Goal 1, put A on B. Okay, to do that, it has to move block C out of the way first. No problem. It moves C, then it puts A on B. Perfect. Goal 1 done. But now it looks at goal number 2, put B on C. Uh-oh, it can't do that. A is sitting right on top of B, blocking it. So to achieve the second goal, it has to undo the first one. It gets stuck in this frustrating loop, breaking one goal to achieve another.
Clearly, a much smarter approach was needed. Something that could handle these kinds of conflicting goals and actually see the bigger picture, instead of getting stuck on one step at a time.
And that solution came in the form of something called target stack planning. Now, the easiest way to picture this is to think of a super organized to-do list. In computer science, they call this a stack. And this list doesn't just have the big goals on it, it also keeps track of all the smaller actions, and crucially, all the preconditions for those actions. Everything is in one place.
So check this out. Here's how this smart to-do list works. First, you just push the main goal onto the stack. Then the AI looks at whatever's on top of the list. If it's a big, complicated goal, it breaks it down, replacing it with the action needed to achieve it plus that action's preconditions. Now, if the top item is an action and its preconditions are all met, great, the AI just does it and updates its view of the world. And if the top thing is a goal that's already finished, it just pops it right off the list. It just keeps doing this over and over until the stack is empty. This is what solves the puzzle. It can add a precondition like, make sure block B is clear to its to-do list before it tries to move block A.
So you can see this is way more than just a fun little puzzle with toy blocks. This was a genuinely huge leap forward. And even though today's AI planners are, worlds more complex, they are still built on these same fundamental ideas. break big problems down into smaller ones, and figure out the right sequence of actions.
And why does any of this matter to you? Because this exact same logic, breaking down goals, checking preconditions, sequencing actions, it's at the core of so much of the technology we see today. We're talking about intelligent robots on an assembly line, figuring out the best order to build something. We're talking about self-driving cars planning a safe path through chaotic traffic. Basically, any time an AI needs to actually do something in the real world to hit a goal, you can bet it's using a much more advanced version of this kind of planning.
There's a quote from our source material that I think just nails it perfectly. Planning is considered the logical side of acting. It's that critical bridge between just thinking about a goal and actually doing something about it.
And that really brings us to a huge critical question for the future. As these AI planners get more and more powerful, more autonomous, the real challenge isn't just about whether they can make a perfect plan to achieve a goal. The challenge is making sure we're giving them the right goals in the first place. So if an AI can perfectly plan its actions, who's responsible if the goal itself is flawed? That's definitely something to chew on. Thanks for joining me for this explainer.